Unit 4, Day 5, surface area of pyramids and cones. So recall that the surface area can be thought of how much material a geometric figure is made up of, or the wrapping paper that it would take to cover the outside of it. And we use nets to help us calculate the surface area of prisms. So example 1, determine the surface area of the following pyramid using a net. So we have a square base pyramid, and here's what its net would look like. So the 2D unfolded version of this 3D version. So now it's easier to calculate the surface area. So surface area of this shape is equal to the area of the square, which is the bottom of the pyramid, plus 4 areas of these triangles that make up the sides. So the area of a square formula is side length squared plus the area of a triangle is side times height divided by 2. So our value of S we know is 10. Now the height of these triangles, you have to realize, are different than the height of the pyramid that we're given. So this 25 centimeters refers to the height of the entire pyramid, whereas the height of the triangular face is actually this diagonal line here. So hopefully you can see there's a difference between the height of the triangular face and the height of the entire pyramid, which is what we're given. So for these types of questions, there's always an extra calculation that you have to do aside, and that is calculating the length of this height here, and we call it the slant height. So to figure out the slant height, if you notice, these form a right angle triangle. So we can use our Pythagorean theorem to find out the height of the triangular face, or the slant height. So slant height is going to be denoted as L, and L squared is equal to this value squared, so A squared, plus this value squared, which is height. So it's just like Pythagorean theorem. So now L squared is equal to 5 squared plus 25 squared, which is equal to 650. And then we take the square root of both sides. So L is equal to 25.5 centimeters. So now we know that the height of the triangle, or the hypotenuse, is 25.5 centimeters. So you can plug that in here. And our final answer is 610 centimeters squared for the surface area of this square-based pyramid. So in summary, just remember that when calculating the surface area for a pyramid, there's that extra calculation of the slant height, because the height that's given refers to the height of the pyramid, not the height of the triangle that makes up the faces in the net. Moving on to the surface area of cone. So here's a cone in its 3D shape, and when putting it into its net, a cone can be broken into 2 shapes. Its circular base, and then a top shape, which we don't really have a name for, but just know that the top shape is this shape right here, and that wraps up to form the side of a cone in its 3D shape. So determine the surface area of the cone below. So here we have the 3D shape, and we've also created the net. So the net is made up of the top shape and the circle. So the area of a circle we know is pi r squared, and the area of the top shape is equal to 1/2 circumference times slant height. So slant height we are going to have to calculate the same way we did for the pyramid. So slant height squared is equal to this side squared plus this side squared. So r squared plus height squared. So this is just the Pythagorean theorem. And then L squared is equal to 8 squared plus 24 squared. L squared is equal to 640. And then we take the square root of both sides. And L is equal to 25.30 centimeters. So now let's do our overall surface area formula. So surface area is equal to area of the top shape plus area of the circle, which is the bottom shape. The area of the top shape formula is 1/2 circumference times slant height. And you can kind of remember that. It's kind of like the area of a triangle formula. This also sort of looks like a triangle. Plus area of a circle, which is pi r squared. So circumference is equal to 2 pi r times the slant height, which is 25.3. And then we can sub in our 8 for r, which becomes 64 once we square it. And now these two numbers cancel each other out. So we're left with pi times radius times slant height plus 64 pi. So we're left with 202.4 pi plus 64 pi, which ends up being 836.92 centimeters squared. And that is the surface area for the cone pictured above.